Hello, my name is Dr. Richard Laub. I am a PhD chemist, former university professor at The Ohio State University, chemistry teacher, and then at San Diego State University. In later years, I formed Laub Biochemicals Corporation, primarily as a research and development company for the purpose of examining humic acid. Humic acid is a soil extract. It comes in deposits from soil. It's found throughout the western United States and indeed throughout the world. It's sometimes called brown coal or leonardite. It doesn't have a very high energy efficiency, so it's not useful as a coal. In fact, it's a very young coal. It's only about 50,000, 100,000 years old, whereas actual coal is more like 4 million years old. But humic acid has some very interesting properties, particularly in terms of human and animal viral disease. It turns out that when humic acid is sourced properly in terms of its chemistry, also when it's processed correctly, it in fact is an all-natural, broad-spectrum antiviral. So it's effective against such diseases as herpes, hepatitis, influenza, hemorrhagic fever viruses, and so forth. So humic acid really is a broad-spectrum antiviral, as established by a lot of research over the years, both by myself as well as many other researchers. The way humic acid works is by preventing viruses from binding to host cells. All mammalian viruses have one feature in common. They have to bind to a host cell in order to reproduce. The virus binds to the cell, the outside of the cell. It then injects its RNA or its DNA into the interior of the cell, which causes the cell to produce more viral RNA or DNA. That material then buds out through the cell wall to produce new viruses, which then go on to repeat the process. That's all viruses do. Viruses don't breathe. They don't eat, they don't sleep, they're not conscious entities at all. They simply reproduce by tricking a host cell into making more of themselves. What humic acid does is bind to the sites on the surface of viruses that viruses use to attach to cells. And so when that happens, the virus can no longer attach to a host cell. Well, what that means is that the virus can no longer reproduce, and the virus then dies out of its own accord. Viruses don't last forever if they're not allowed to reproduce. For example, influenza viruses only last a day and a half or so if not allowed to reproduce in a medium. And so if you were to get the flu and you took humic acid to treat the flu symptoms would last, in fact, about a day and a half, because the virus, not being allowed to reproduce, dies out. And it also gives the host immune system a much better chance of eliminating the virus from a mammalian system. So that's the way humic acid works. It's an excellent therapeutic. It's also a very good prophylactic, so that by taking humic acid on a daily basis, you can, in fact, prevent getting colds and flu. The humic acid material that is good for human consumption purposes is not just limited, however, to an anti-flu medication. Material is also, as I mentioned earlier, broad spectrum. That is, it really is effective against diseases such as dengue fever, which is a hemorrhagic fever virus. It's also effective against herpes, simplex 1, simplex 2, varicella zoster virus, for example, Epstein-Barr virus. In the case of herpes simplex 2, which is generally associated with genital herpes, one would take 1 tablet twice a day to prevent viral outbreaks. But if a viral outbreak were to take place, a simplex outbreak, one would increase the dose to 1 tablet 3 times a day. That would do a couple things. First, it would certainly shorten the duration of the outbreak, and it would also lessen the intensity of the outbreak. So what we found is that herpes sufferers who routinely have 6 to 8 outbreaks a year, by taking humic acid on a prophylactic basis, can reduce that to 0 to 1 outbreaks per year, and if an outbreak does occur, to greatly reduce the duration and the intensity of the outbreak. In terms of simplex 1, something like 85% of all Americans are serum positive for herpes simplex type 1. This is the virus that gives rise to little rashes above the lip, cold sores on occasion. Well, those are easy to deal with, but some people have whole mouthfuls of cold sores at one time, or serious rash coverage of their facial area. Well, that's usually herpes simplex 1. Again, by taking humic acid on a prophylactic basis, usually 250 milligrams a dose, 1 tablet or capsule in the morning, 1 at night, the number of simplex outbreaks can be greatly reduced. There are other uses for humic acid as well. Currently, for example, there are a number of animal viruses that affect ordinary household pets. For example, cats, if they're not vaccinated, can easily come down with what's called feline leukemia virus. Dogs, if they're not vaccinated, can easily attract parvovirus, which in fact kills the dog in about 5 days, mostly due to dehydration. Well, these are all viral conditions, and these are animal viruses that again can be prevented by the use of humic acid in pet food. Home aquarium use is another good outlet for humic acid. Fish are subject to viruses, particularly koi, for example. Koi herpes is a very serious virus. And of course, some koi cost in excess of thousands of dollars. But by simple use of the fish version of humic acid, a koi herpes virus can be prevented. So once again, humic acid is a broad spectrum antiviral agent. That is, it works against many different types of viruses. The reason that it's broad spectrum has to do with the molecular size of humic acid. Humic acid itself, the molecule, is about 50,000 Daltons on average. Its considerable aromatic character gives the molecule a planar shape, so it looks kind of like a frisbee or a big floppy beach hat, if you will. Mostly flat, but flexible. And so when humic acid encounters a virus, and the virus has a binding site geometry of some sort or other, humic acid molecule is flexible enough to conform to that binding site, that is, block the virus from preventing attachment to a host cell. Humic acid chemically is a very sticky molecule, as are the binding sites, as you would expect, on the surface of viruses. And so bringing humic acid together with a virus is kind of like bringing together 2 pieces of Velcro. They stick together. Once they're stuck together, they're hard to get apart. But what this means is that humic acid can even work once viruses have attached to a host cell. That is, when humic acid is administered to viruses that have already attached to a cell, humic acid can actually displace viruses from cell surfaces. And so humic acid in that instance acts as a very effective therapeutic agent. That is, it can actually stop and reverse viral infection. Now, other molecules that you may have heard about that are similar, something like fulvic acid, for example, are not nearly so effective, if effective at all, against viral infection. The reason is that fulvic acid, for example, is a small molecule version of humic acid. Fulvic acid is only about 1,500 Daltons molecular weight. And so fulvic acid, since it's somewhat aromatic in character, again being a stiff molecule, is not nearly as flexible as the large humic acid molecule. So that being the case, fulvic acid can't conform to the binding sites on the surface of viruses. So fulvic acid, by and large, is not effective as an antiviral agent. It's a great mineral supplement, but it's not a good antiviral. Humic acid, on the other hand, being a large flexible molecule, is very effective as an antiviral. It's also a good mineral supplement, just as fulvic acid, but it's also a very effective antiviral agent.